Let's have a look at question 3. A particle P of mass m is held at rest at a point on a rough inclined plane, as shown in figure 3. It is given that the plane is inclined to the horizontal at an angle alpha, where tan alpha equal to 5/12. So straight away, I will draw a little right angle triangle. So this is alpha, it says 5/12 for tan alpha. So that means opposite is 5, adjacent is 12, so hypotenuse has to be 13. Then we know sine alpha is 5/13, and then cos alpha equal to 12/13. So we're probably going to need that later. And then the coefficient of friction between P and plane is mu, where mu is less than 5/12. And then particle P is released from rest and then slides down the plane. Air resistance is modeled as being negligible using the model. Find in terms of m and g the magnitude of the normal reaction of the plane on P. So let's draw all the forces out. So the weight has to be mg, and then the normal reaction is equal to r, and then resolve the forces, one perpendicular to the plane, one parallel to the plane. So if this is alpha, then this has to be mg cos alpha, and this one would be mg sine alpha. And then because it slides down the plane, so it has to be friction goes upwards. Wait, let me try it out. Yeah. So the friction should be goes up. And then friction is equal to mu r, or just label as friction first. Yeah. And then they want us to find the magnitude of the normal reaction. So in part A, the force, if we look at the force which is perpendicular to the plane, because the particle only moves parallel to the slope. So that means the one which is perpendicular to the slope has to be equilibrium. So up has to be equal to down. So R has to be equal to mg cos alpha, because that's the only two forces perpendicular to the slope. R goes up, and then mg cos alpha goes down. And then we know cos alpha is equal to 12/13, so we just have 12/13 mg. And that'll be the answer for part A. Very simple, 2 marks. And then for part B, show that as P slides down the plane, the acceleration of P down the plane is equal to 1/13g times 5 minus 12 mu. So as long as the particle moves, so we can just use F equal ma. So F equal ma, F is the resultant force since the particle goes down the plane. So force goes down is mg sine alpha, which is this one. And then force goes up would be the friction. So minus friction is equal to mass times by acceleration. And then because the particle is moving, so that means the friction has to be the maximum friction. We can just use mu r. And then we know r is equal to 12/13 mg. We already worked it out in part A. So simplify that, divide by m for both sides. And then they want us to leave in this form. So we just have to check what do we know so far. So first we change sine alpha into 5/13. So 5/13g minus 12/13g times 5 mu is equal to a. So we have both of the terms has 1/13 in it, and then both of them has g in it. So that means we can factorize 1/13 and then factorize out g. So what is left for the first term is just 5. And then what is left for the second one has to be 12 and also mu. Then that's what the acceleration is. Okay. And then part C, state what would happen to P if it is released from rest, but mu is more than or equal to 5/12. So now, as long as they're talking about where the particle going to move, we need to check the direction which is parallel to the slope, because if the particle going to move, it has to be moved alongside the slope. So we have to use the forces parallel to the plane. So the only two forces I already highlighted in here is either mg sine alpha or the friction. Yeah. So mg sine alpha, we know it just sine alpha is 5/13, so 5/13 mg. And then the friction is equal to mu r. So we know because so mu is just mu, and then r we already know is 12/13 mg. And then we know mu has to be more than or equal to 5/12. So if mu is more than or equal to 5/12, so that means the friction has to be more than or equal to 5/12 times by 12/13 mg. So which friction has to be more than or equal to 5/13 mg. So because mg sine alpha is the downwards force is equal to 5/13 mg. And then I just showed in here, the friction is more than or equal to 5/13 mg. So if the friction is bigger than the downwards force, so then it shouldn't move downwards. So it should just stay at rest. Because you have to be more than the force, the downwards force has to be bigger than the friction to make the particle move. Otherwise, it will stay at rest. So you just have to say the particle P will continue stay at rest. And that will be the final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.